Good afternoon. Welcome to our first example in the new section. So let me kind of set the stage a little bit. The directions for this problem are to determine the force in member DC, HC, and HI, and then determine whether they're in contention or compression. So it does not say that we have to find the force in every single member. It does not say that. So we're going to look at a technique today called method of sections. So in the previous method of joint, we went from joint to joint. In this method, we're going to literally cut the truss or the structure into sections. And in the method of sections, we cut through 3 members to produce separated sections. So we're literally going to cut through 3 members of this truss to produce 2 separated sections. I wonder which 3 members we could cut through to produce 3 separated sections. Okay, so that's kind of where we're headed. Now the first step, of course, is to, let me write it up here so we have it in our notes. Prior to our cut, get reactions at our supports. Okay, so we still have to do that. So we'll get reactions to our get reaction forces to our supports. We'll cut through 3 members to produce separated sections, and then we'll determine the forces. Let me pause for a second while I erase the board. Okay, so the original picture at joint F had a roller support, so perpendicular to the plane, and at point A had a smooth hinged or smooth pin joint. So we have an AX and an AY. We'll just kind of walk through our process. All right, so well, immediately looking, if I take the summation of the forces in the X direction, I get AX is equal to 0. I'll go ahead and just write that here. Summation of the forces, well, that's not true, is it? Already a mistake. Because we do have these other 2 forces, don't we? Yeah, so AX is plus negative kilonewtons plus negative 40 kilonewton force equal to 0. AX plus negative 70 kilonewtons equal to 0. AX is equal to 70 kilonewtons. So the fact that it's positive just means that I made a correct assumption in the direction of the force. Summation of the forces in the Y direction, we have AY plus FY minus 40 kilonewtons minus 50 kilonewtons. Find those terms that are alike. We get that AY plus FY minus 90 kilonewtons is equal to 0, or AY plus FY is equal to 90 kilonewtons. That's one equation, 2 unknowns, tells me that we're going to have to take the moment about a point. Since there are 2 forces at point A, I'm going to take the moment about that to kind of reduce the work. Moment about point A. So AX is not a player, AY is not a player, 40 is a player. 40 kilonewtons. Perpendicular distance between B and A is 1.5 meters. 30 is a player, 30 kilonewtons. Perpendicular distance between 30 and A is 3 meters. 50 is not a player. 50 goes through point A. The perpendicular distance will be 0. The upper left-hand 40 is a player. Its perpendicular distance from point E to point A is 2 meters. And finally, Fy is a player. And its perpendicular distance, the distance between Fy and point 8 is 4 meters. Grabbing our direction. So if we are about point A, applying force at B from right to left causes a counterclockwise, which is positive. At point C, where the 30 kilonewton ones also would produce a positive 40 kilonewtons. At point E also produces counterclockwise, which is positive. And Fy, as I have it indicated, would produce a negative. I'm thinking that we're probably right about that one. 4 times 1.5, 40 times 1.5 is 60 kilonewton meters. 30 times 3 is 90 kilonewton meters. 40 times 2 is 80 kilonewton meters. And this is plus negative Fy times 4 meters. Combine those terms, they're like 60 plus 90 is 150. 150 plus 80 is 230 kilonewton meters. Minus Fy times 4 meters equals 0. Solving for Fy, we get that Fy is equal to 230 divided by 4, which I think is 57.5 kilonewtons. 5 kilonewtons. Let me fill that in. 57.5 kilonewtons. Placing that into the summation for the y's, that would give us AY plus 57.5 kilonewtons equal to 90, making AY equal to 32.5 kilonewtons. Go ahead and fill that in. I'm going to pause the video here now that we have the support forces at the supports. Erase the board so that we can go on to the always exciting second. Okay, welcome back to a brand new clean board. All right, so the method that we're looking at again is called method of section. So we're going to make a cut. The cut has to go through, remember, the cut has to go through 3 members. And when we cut through those 3 members, we should have separated sections. Now we're asked to determine the force in DC, which happens to be right here, HC, which happens to be right here, and HI. So that's where we're going to make our imaginary cut, if you will. So pretend like we cut through those members, and now we have 2 sections. We have 2 sections. We need to choose one of them to work with. It does not matter which section we choose to work with. What does matter, though, is that we choose one of them. I'm going to choose the lower section. So I'm going to pause the video real quick. I'm going to draw a free body diagram of just the lower section. All right, welcome back. Thank you for your patience as I took a couple minutes to draw the free body diagram for the lower section. So remember what we did. We literally took a cut. Let me erase it and redo the cut so we see it. We literally did a cut. Nice big green cut. We literally did a cut through 3 members And when we did that cut, it separated our structure into two pieces. We happened to cut through the three members that we were looking to determine the force of. Not a bad strategy. That's a great strategy every single time. Every single time. Big guess. I mean, at this point, it's since the truss started out at equilibrium, looking at a section of it, we will assume that the section is equilibrium. Not assume, I mean, it's a guarantee. Because it's the equilibrium, we'll be using equilibrium equations. Now remember, we're looking to get three forces: force DC, force HC, and force HI, or the forces for those three members. I guess before we get started, we should go ahead and take a look at DC. So DC is at an angle. I have it going up. So, of course, everything didn't line up. All right. DCX, DCH, or I'm sorry, DCY, and the perfectly straight DC. DCX, and this is DCY. So from the measurements in the top picture, this theta is equal to the arctan of 1.5 over 2. I'll calculate that out real quick. Arctan 1.5 divided by 2 comes out to be 36.87. 8699, I guess, really, though. So theta 36.87 degrees. So DCX is DC cosine 36.87 degrees. DCY is DC sine 36.87 degrees. Well, I tell you, if we do it take the summation of these forces in the x direction, we have two unknowns. We'd have HI and DC. I'm sorry, HC and DC. If we take it in the y direction, we have two unknowns, HI and DC. What if we go straight to a summation of moments? I mean, if we went summation of moments about about point C. Summation of moments about point C. That eliminates DC, HC, and this 30 right here. So the only players would be HI times the perpendicular distance between HI and C, which is 2 meters. The 70 kilonewton force is a player. Perpendicular distance between point A and point C is 1.5 meters plus 1.5 meters, so 3 meters. 32.5 is a player. Perpendicular distance between A, Y, and point C is 2 meters. So 32.5 kilonewtons times 2 meters. And the 40 kilonewton is a player with a 1.5 distance. So 40 kilonewtons, 1.5 meters. Let's go grab our directions real quick. If we're taking about point C, HI is going to cause a clockwise rotation. Clockwise is negative. 70 causes a counterclockwise, positive. 32.5 causes clockwise, negative. 40 causes clockwise, negative. I'll pause right here while I do the calculations. All right. From all the indicated arithmetic, Combining like terms, I eventually get down that 85 kilonewton meters is equal to HI times 2 meters. Divide both sides by 2 meters, and we get that HI is equal to 42.5 kilonewtons. So we'll fill that in. I'm going to erase this arithmetic to prepare ourselves for the next piece. And I don't, welcome back. I don't see any other way to go about this now. I mean, we could, I suppose, start messing around with some other moments, but I'm noticing at this point that we could take the summation of the forces in the x direction. All right, so those are the 70 kilonewton force down at point A, minus 40 kilonewton force at point B, minus 30 kilonewton force at point C, and I have indicated a minus HC force. Of course, it's wrong. Why is it wrong? It's not wrong. And we have the DC force. So DCX, which was DC cosine 36.87 degrees, which is equal to 0. That left us two unknowns. Let's take a look very quickly at summation of forces in the y direction. Summation of forces in the y direction, we have 32.5 kilonewtons at point A. We've got 42.5 kilonewtons at point I, that was the HI. And we have, oh, bingo. We have the DCY, which is DC sine 36.87 equal to 0. Combine those forces are alike. 32.5 plus 42.5 is 75 kilonewtons plus DC sine 36.87 is equal to 0. Subtract 75 from both sides. Divide both sides by sine 36.87, and we end up with negative 75 divided by sine 36.87, giving us a force of DC of negative 125 kilonewtons. The negative indicates that I have guessed incorrectly with regards to what's going on at pin C. So let me correct that in our picture. The red is correct. Fill in our scorecard. DC is 125 kilonewtons. HI was 42.5 kilonewtons. HI was in tension, pulling away from the point. DC, the reaction is compression, pushing into the point. Since we know DC, we can fill that in right here. So from here, we'll work up. That's making sense like that. All right. So summation of forces in the x direction. Combine those terms are alike. We'll take care of that real quick. 70 minus 40 is 30. 30 minus 30 is 0. All right, so that leaves our summation of forces in the x direction. Negative HC minus 125 cosine 36.87 is equal to 0. Add that to both sides. I'm sorry, add HC to both sides. Negative 125 cosine 36.87 is equal to HC. That gives us a value, cosine 36.87. That gives us a value of -100 kilonewtons is equal to HC. The negative, remember that doesn't mean the force is negative, it just means that I took a wrong guess on what direction HC was. Go down here and correct it real quick. Now indicating going into the pin, so 100 kilonewtons at compression. Now, we could, if you guys and gals want to, we could have worked this problem using the method of joints. Starting at joint A down here, working up through joint, probably joint B, then joint I, that would have gave us HI, up to joint C, that would give us DH, DC and CH, or we could have started over here at F, probably went over to G, up to E, over to D, that would give us DC, down to H, that would give us HI and HC. We could do that, or take advantage of the fact that there's a method called the method of sections that allows us to take a cut through our truss through 3 members. We've chose with intent the 3 members we were asked to find the internal force of much quicker. Hope you enjoyed this. See you in the next video.